Today we're going to be taking a look at my DIY carbon fiber chopper. I put on a mask, got my speed controller over here. Get it started in the feeder. That's what it does. Now we're going to take a closer look at how it works. I have chopped many rolls with this now, and it's pretty efficient. First thing to note, your carbon fiber quality matters. This is a really nice flat toe. It's pretty even. Some rolls are better than others, but this is a really nice one. So if you feed in something that looks like this, it doesn't matter how good your chopper is, what comes out is going to be no good. On the other hand, if you take a really nice carbon fiber like this and you feed it into an off-the-shelf chopper, it just ruins it. So you've got to have both elements in order for this to work. Good carbon and a good chopper. I'm going to go ahead and take this apart and show you how each piece works. First off, I have this on here to keep carbon fiber from going inside of the air intakes for the drill. Take that off, but you don't want carbon fiber filling up your drill. It's a little bit electrically conductive and also will just manually clog the intakes. Okay, so I guess we'll start here. This is the actual chopping element right here. So it's contained inside of a 3D printed set of parts. This piece includes this circle right here, which is a guide for the carbon fiber. This is an off-the-shelf titanium ring from Amazon that's just attached into 3D printed parts with a couple of bolts. So it keeps the carbon fiber from being able to go too far away as it's going back and forth across the roll. So that will ensure that the carbon fiber stays in the blade cutting area. If it gets off at all, if you don't have something keeping it there, then it's going to go off to the sides of the blades and you're going to end up just ruining your carbon fiber and not getting it chopped. The drill is attached to the holder. I'm going to undo these screws. So this is, again, just an off-the-shelf drill. I haven't done any modifications. I just simply put the hex head on here that matches my bolt. And the existing holes in the drill are where these screws right here slide in, help to keep it stable. A note on the drill. You don't want to be standing there holding this button the whole time, so you just press the button here and lock this in place and just leave it that way, because the way that you're controlling the power is with a speed controller that it's connected into. So you can just use the dial to slowly gear up and get just the right speed to chop the carbon at the correct rate. This is just another 3D printed supporting piece for the drill. And all of these parts are attached into the bottom. I countersunk the head so that this would still lie flat, but everything's attached to this cutting board, HDPE cutting board. Again, just off the shelf item. And I just cut this with an oscillating cutter. It's not the cleanest cut, so I put some tape over the edges to make sure that it wouldn't catch on things and would stay clean, not have any dust getting into my carbon. Cleanliness is a huge thing when you're chopping the carbon, because obviously you don't want contaminants in your carbon fiber. So once this guide sends the carbon down here, next it goes into the rollers. This is a rubberized roller, and this is just a metal one. It doesn't do a whole lot, it's basically just a guide, but this one does heavy duty work in this. It's extremely important. These are dovetail joints to hold the guides on here. Well, they're not really guides, they're really just the locking pieces, I guess. And that releases the entire assembly here. Top piece, this is a metal roller that came in this set of blade parts, because these pieces here are off the shelf. This was printed in multiple pieces and then epoxied together with some little pieces of filament as guides. And then this, of course, off the shelf hardware. So there are screws back here. Turn it around. These are extremely important. These are the tensioning screws. So right now I have them tightened up. When I loosen them, those, now that releases this. So when everything is together, what these screws do is push it a little forward or a little back. The 3D printed slot here is not a perfect circle. It's a little bit elliptical so that this has just enough travel room that I'm able to tension the rubber roller that feeds the carbon against the blades. And this has to be changed not just once, but every time you have to change blades and throughout the process, because the blades wear down. The roller wears down, so you have to tighten up this tension a little bit, push it a little bit harder once the blades get a little bit shorter. This is 3D printed in NinjaFlex, and it's a whole assembly with bearings, bolts. Obviously, this is all off-the-shelf hardware mixed with the 3D printed parts. And this has been used quite a bit, so you see it's worn down somewhat and dyed dark from the carbon. So this is a consumable. It does have to be replaced eventually, but it lasts many rolls. Next piece is the cutter assembly. You can buy this off the shelf. I added in my own hardware. This is one long bolt that goes all the way through. So this is tightened down really hard. I'm gonna need to get pliers to show you how this works. But we'll just finish up with the 3D printed parts, I guess. This was printed in multiple parts, and then I epoxied it together with some little pegs there to keep the placement correct. And that's how I was able to get really clean ledges inside on both sides. You could do supports, but supports make things not quite as smooth. And when you're doing something that's really detailed and needs to be quite precise like this, I prefer to just simply print parts in separate pieces and attach them together. So you see there's a little bit of a ledge on this side and a ledge on that side, and that's what everything slides into to lock in place. Let's take that out. There is a recess here for the nut. It does not go all the way through. So then you just set the nut in and it's flush. And then the screw comes through from the other side. And it cannot pull back out this way. So you get back pressure against the roller and it pushes straight against the bearing here. So it doesn't in any way impede this from spinning, but you can press it more or less to get it closer or further from that chopper piece. It goes all the way through right here, so there's free room for the carbon fiber to go flying off the blade, and it will kind of go crazy sometimes, but most of it does go straight down the chute there, or hole. This one doesn't have a chute. So let's take a detailed look at the blade assembly. This is on there very tight because I don't want it unscrewing from anything else. It needs to be turning on these two bearings. 3D printed a tool for this. Actually, it was a failed part, but I ended up keeping it as a tool. There we go. Off the shelf standard bearing, little divider thing, the spacer that I found. It looks like it's scratched up a little bit inside now, but that's fine. So this is one bolt going through the entire thing, but I don't need to take this bolt out right now. So with an assembly like this, you have to be able to change these blades pretty frequently. Like they'll go maybe 2 or 3 rolls, but after that, you got to change it. So on here, in order to get the carbon fiber to feed properly, the way that this comes, there's nothing in here. You can add extra blades if you want to. These are pads that I have to add, and I have to change these whenever I change the blades. So I'm gonna peel those off. I'll show you what these are made from after we go over the blade assembly here. Okay, so I would normally take all of them off, but I'm gonna just go ahead and pry this off now. And this is how it's intended to be used. It is a part that's designed to work with these specific blades. I have a bunch of replacements for. This rubber ring pops out, lets you pull out the blades and put in new ones. You can put in more or less blades depending on the length of carbon fiber that you want chopped. This makes it about 1/2 inch. So you can easily change the blades without having to take apart the bulk of your assembly. And because this screw goes all the way through the threads, there's no chance of it like wearing anything or getting misaligned with the threads. Super easy. So then once you change the blades, which I'm not going to bother doing right now, add everything back in the correct order. Okay, so we do the top, the spacer, then the bearing, then the nut. These little guys are getting stuck all over me. And then tighten everything back up so that it's ready to go back into the full assembly. See? Already tightened. Okay. This is what I use to make those foam pads. They're off-the-shelf item. So it's just weather stripping, but I found that this has a perfect thickness and texture to help pull the carbon through in as a team with this rubber roller on the other side. Because when the carbon fiber is against these blades, there's such a depth that I found without these pads, it just either won't pull through or it messes up the neat flat row of carbon fibers more and will break them up. So you've got to have the foam. And this is self-adhesive. So first I clean this off a little bit with some alcohol to make sure I get good adhesion. Cut a piece that's approximately the length of this section. And then trim off the edges just a little bit, just bevel those. Just gonna help it settle in place without any bits of it getting stuck over the blades and getting cut off and mixed into your carbon. Just check, make sure it's the right length. Yeah, it's fine. It's fine if it overlaps that a little bit. Just don't want it overlapping this. And then just place that in the center between the blades. And then you repeat that for every section of blades. Every time you change the blades, you gotta change the pads. As I was doing this, I remembered that, yeah, I used to use the gray one, but I got myself some black, so this is what the packaging for that looks like. The idea being that if a little piece of this were to break off and get into the carbon, which I've never had happen, but because I always check through and make sure I pick out any bits when I'm first starting the blades, but if it were to get in there and I were to miss it, I'd rather it be black because then it's not even gonna show. So I'm gonna switch over and use the black one instead. It's the same thing though. Gotta remember to trim off the edge. This again helps to reduce the chances of any pieces getting nibbled off by the blades and ending up in your carbon. As they get squashed down, it kind of mooshes out. Like you'll see, this is what happens after it's been used for a while. It does kind of get squished and spread out. So if it squishes past and gets over the blade, then that's how you get a tiny piece cut off. But that only happens very early on when you've just changed the pads. So as long as you're paying attention, any little pieces that get cut off early on, you just pick them out and then it's good to go. Still though, might as well use the black. Nice fresh pads. I'm gonna put this back together now. So we have the roller, as you see, has a little plate space to move in there. Just gotta make sure this is all the way out so that I can get the blade in. Blade assembly, it's a little longer on this side. That's where the drill will go on. So I'm gonna make sure I put that the correct direction. And these just line up with the little recesses here. The bearings stay in place. It's only turning the bolts with these attached to them. Oh, one note on this. This is just pressure fit onto some bushings here and these little spacers that are 3D printed combined with the hardware. But yeah, that didn't need to be anything crazy. A good pressure fit was plenty. Versus this, it's screwed all the way through because there's a ton of pressure on this. This is where the drill is spinning, so it needed to be attached really, really well with that metal center cutting wheel. Okay, there's that. Next is just the guide piece here, and it has the opposing slots on each side. So these can kind of turn a little wonky, but they just get aligned vertically and slide into this groove on each one of these. Oh, I have it backwards. If it doesn't fit, that's how you know it's backwards. There we go. So that just creates the circle for each of these elements. So those are all kept in place. The bearings are going to be locked in place so that they will spin on their bolts rather than moving around within the 3D printed part. I have a locking piece here with a dovetail joint that slides in and ensures that nothing shifts around. Same for the other side. Mates up with these pieces sticking up here. And then the top piece, which you definitely have to have this ring. So you have to have some sort of top piece, but it also, because it's got a rim here all the way around, it just is the final piece to lock everything in place. So this here by itself is no good if you don't have a good system for feeding the carbon fiber. So that's what we're going to look at next. A lot of people saw the video I did where I was going over some of these parts with 3D printing tips, so you'll recognize some of the pieces here. The key with this is that it's very balanced, very smooth. Everything is easy as possible to turn. So these rolls of carbon fiber are extremely heavy. And if you don't have a good bearing, well, it doesn't have to be a super special bearing, just a bearing for each side here, then the chopper is not going to be able to pull it. There's going to be too much back pressure when the roll is full to be able to feed the carbon fiber just by the front and back roller squeezes this and pulls it. But if there's too much back pressure, too much resistance, then it's going to pop out from between those rollers instead of getting fed through. So I'm going to take this apart and show you the elements of it. This is kind of overbuilt, but the rolls are so heavy, I just wanted it to be like really easy to move around. You can pick it up by any part of this when it's all attached together, but we're going to take it apart. These screws have been customized a little bit to be easy to turn by hand. It's just a 3D printed part that slides up in and it's pressure fit with the top recessed. I like making these for anything that I want to be able to quickly do, like quickly turn without having to grab any extra tools. This piece just locks that in place over the bearing and the center pole that attaches to the carbon fiber spool itself. Right here there are embedded in this nuts so that I'm screwing into an actual metal nut, so it's a very secure connection. I'll show you how that's inserted in just a second. Same setup on the other side, just have to remove these two screws by hand. These are the same parts on this side, that's symmetrical. Now I can remove the entire spool. And these are those parts that I had filled with old resin to make them really sturdy. The nut that's in here, it's not actually meant to be really taken out, but yeah, so there's a little rubber cap. I think I printed that in TPU. And inside of that is a slot so that you can insert the correct size nut. Of course, the hole has been sized for this specific nut. It's part of my system of standard sizes that I use, but that's how each of these vertical parts has its bolt attached. Same concept as with the chopper. This is a off-the-shelf HDPE cutting board with recessed holes here for the heads of the screws. Those screw up into the 3D printed part that has a recessed nut. This has a little recessed part here that the bearing fits into. And that's about that for the parts that hold it. Okay, the parts that I'll attach to the spool. So this carbon comes on a standard size cardboard spool. So when I need to change a spool, actually I'm gonna do it from the other side. I think I normally do it from this side. They're the same, but some of them I have them screwed in tighter because I don't take them off. So this one they're not tightened all the way. It's easier for me to change it out. This piece, again, you might recognize this from another video when I was printing these separately and then plastic welding them together along the seam. These need to be really tough and everything needs to just be really precise. So that's why I put so much effort into printing these the best way I could come up with. So this piece obviously has a handle. This is just to cover the end of the bolt so it's easy to hold on to and doesn't get caught on anything. And I haven't taken this apart since I first made it. I'll make sure I keep it, oops, all in the correct order because I might not remember how to put it back together. Okay, so this is matte fiber HD PLA from Protopasta, and it was printed in 2 parts that I plastic welded here so that I could ensure this side was printed really, really well and this side was printed really, really well without needing support structure, because I find support structure kind of tends to mess things up a little bit when you're trying to make something precise. So there's a slot right here that allows a nut to be pushed down into that. And then this screw, it just has a 3D printed part that's plastic welded over the top. I just filled it in with plastic after I threaded the screw through. And that goes in here. Now there is a little tiny opening there that lets this pipe, which I'll show in more detail, slide in there so that when this screw goes through, it's actually going through the hole in this metal pipe. So that ensures this is locked in really, really well. And when this turns, the pipe with the carbon on it also turns, but the bearing stays still. Okay, so let's put this back there. So we got bearing, then we've got this 3D printed washer thing that ensures the pressure is put onto the inner part of the bearing. Because always when you're using a bearing, you have to make sure that the bearing is held on the outside and everything else is only pressing on the inside. Otherwise, it's not going to help you at all. I think this goes on next. I'll be honest, I don't remember why this piece is... Oh, yeah. So when I first made this, I made this piece that fits over out of rubber because I thought I was going to need to have some kind of a stopper. I didn't end up needing that, like to slow it down. But these big rolls are so heavy, and just the thing itself is built so differently from the first version of my spool holder that I made, which I'll show you later on, that I didn't end up needing that feature. So that's just a vestigial feature. This mates with that, so these pieces go into the holes here. So that when this turns, which is glued to this, just with hot glue. Now this one I don't have it glued in right now because I glued it from the other side. But this piece is reusable between spools because I just use hot glue and then I'm able to grab it with my fingers and pull it out. So it's not a consumable. Just need a little bit of hot glue each time you reinstall it. And then that is of course sized to fit with a specific spool. It's the same exact setup on the other side, so I'm going to just pull out the whole metal tube. So what's happening is you'd have your spool on there. This attaches into the spool. I have markings on here to help me align it. So it would be here, and then this piece goes on. It's hard to do without the spool on there. This piece goes on there so that it aligns with this. And then you tighten down these screws. You can tighten them all the way, but then that's locked on. So now when the bearing is held here by that slot that it fits into, this turns, everything turns. So when the spool is being pulled, it just spins everything smoothly on this bearing. So these 2 bearings, one on each side, symmetrical part here. And changing the spool is pretty easy. So if I didn't have one glued in here already, then I would just glue this with just a couple dabs of hot glue into one side. Now this is attached to that. Pole slides in. You only have to take off one side of this. And there's a little bit of a spacer here to work with the sizing of the cardboard spool. So that just slides in here. Those align into the correct grooves. Flip it around. Add the same thing on this side. Normally I glue it in with a little bit of hot glue. The pressure fits pretty good though, and the other side's glued securely, so I'm not going to bother. And align it so these openings are aligned with the hole for the screw. This piece slides on, aligning with the correct slots, and then that gets tightened down. And the whole thing just plops into the recess for that. And then we'll just screw down these now to make sure I get it the right way. There's a shorter side here to make sure it does not touch this. We don't want any friction points at all. Very smooth, very quiet, because it's all aligned, and because that inner tube is metal, that adds a really good amount of rigidity, so it all works together to feed as efficiently as possible. I actually would turn around and have the carbon feeding from the top, and then this end would feed into the chopper. I find that that works best because the height of the carbon aligns more with the top of the chopper. Now let's take a look at the version 1 for this whole setup. So this was supposed to just be a prototype, what I have here, but it actually ended up working for me for quite a long time. And I was able to identify the real problems with it so that my next version could be significantly better. But even this, as it is, was a functioning model. This hole here is where the drill would go in, and then screws would come down from the top to lock it in place. And then I had a piece of something here just propping it up so there wouldn't be all the pressure just on this one part. So it's the same concept. This would turn this screw that's attached to the chopper. Very similar in that respect. And when I was first starting, I had this type of switch for it versus what I have now, which is a much more controllable speed controller. This is just not very fine-tuned. It kind of moves from the vibrations, so I had to actually tape it down in whatever setting I wanted it to be on. So this is far superior. And it's very easy. You can use it with anything because it just has a standard plug. Just plug your drill into that, or whatever power tool you want to be able to control like this instead of having to push a button. So this is a good upgrade from this one for sure. All right, so similar concept. You can see where that came from with the last one. A piece that slides off the top like that. This is the guide. This is just another, I think it's a titanium ring for rock climbing. It's just something I had, and it's very smooth. That's what you need, is something very smooth, because you don't want friction. All of your carbon is going to be sliding against this part. So if you have something that's not smooth here, it's going to be tearing up your carbon every time it goes through. You're not going to get as good of a result. So this kind of looks similar. Now, this isn't the right part right here, but that copper colored roller that's on the other one is supposed to be on here. This is retired now, so it doesn't have all the same parts. Now, it was mounted on this scrap piece of wood that I added some foam on the bottom to help with the vibrations. Again, this, I didn't expect to actually use this. It was just a prototype, but yeah, so it's kind of not the nicest looking thing. Again, just a scrap piece of wood that was screwed in here to help support the drill. This here is the chute for the carbon fiber to come out. It needed to be smooth so that it wouldn't get caught in the chute. It needs to go out. It didn't do that perfectly, but it was okay. So this is actually a separate piece. It's 3D printed, and it has these screws on it, so that has something to rest on at the back. And then a little piece of the Teflon coated peel ply was taped over the top. Because this is kind of textured, the carbon would definitely get snagged on that, but it slid over this pretty nicely. So this one is not nearly as nice with regards to being able to take it apart easily. In order to change blades, I have to actually unscrew all of these screws here. So that was one of the biggest pain points that I found after using this for a while, is that I knew I needed to make it as easy as possible to take it apart and change the blades, because that has to be done frequently. The chopper assembly is basically the same, except here it's a bolt on each side. I didn't at that point have a bolt that was long enough to go all the way through, and I thought that this would work. They're just tightened, against each other, but this would come unscrewed sometimes. And when it comes unscrewed, it is a catastrophic event. It completely ruins the carbon because it just keeps feeding. I mean, there's no sensor on here. So if your carbon is getting destroyed, it's just going to keep happening until you notice and manually stop it. So that was another big problem that I had to fix for the next one by having one single through bolt. Other than that, the concept with this is the same. There's bearings on each side. You can kind of see that there, so that this can spin freely. Obviously, you wouldn't want it directly against plastic parts because that's going to just heat up and deform. So you really have to have metal bearings in there. At the back, I'm missing one of these. There's supposed to be two of these. These are, again, the tensioners. So the concept for that was already there. It already worked. I was already using a 3D printed roller. So the roller that comes with this chopper assembly, when you're buying one of these sets, it's this white roller and it just doesn't work. It's a little too narrow for one, but the texture, the softness, whatever it is, it just didn't work. It wouldn't feed the carbon through properly. So that was when I started 3D printing my own. And I used the same piece that goes in the center there for it at that time. So I sized the hole to fit with those existing parts, and then I just played around with the diameter, the placement, the layer height, the infill, until I found what worked with this. It has to have just the right amount of firmness and texture in order to properly pull the carbon fiber through. All of these things have to work together. So I still have the pads on the cutter there, nothing different with any of that. And then this guide just keeps the carbon fiber down as it feeds through. So I'm not going to take this apart, but yeah, to change the blades, I have to unscrew all of this, pull this entire piece off, and then I can extract all of these pieces here to be able to change the blades, because I have to take this whole cylinder out to be able to change the blades. Yeah, so this would go back on here. And the carbon fiber, same as the other one, feeds in, oh, whoops, nope, that's backwards. Carbon fiber feeds into the hole. This is just a viewing hole so that I could see my blades and monitor it better. But this hole with the smooth metal ring is where the carbon fiber would feed in and then get grabbed by the blade. That comes out this side, and if you have it tensioned up, then what comes out is chopped up. I was editing this video and realized I completely forgot to even record anything about the old spool holder here. So I'm back to record that. So we have a scrap wood frame with some foam on the bottom for absorbing some of the vibrations. When I'm making a first prototype, I try to just work with whatever I already have on hand. So that's why these have just random things sometimes that are making them. And I printed these open here because I didn't think they needed to be very strong for a first test. I didn't even expect it to work, but it ended up working well enough. So here I was using this rather fragile looking part. Okay, so this here is for, what do I call it? I guess slowing it down. It's a brake. It's basically a brake. So when you turn this handle, it moves the screw out, and then that will create friction against the 3D printed part that's in the spool. I made this overly fancy handle because I thought I was going to need to like do it quickly and easily and have it be comfortable and everything. But this is way overcomplicated for what it is. Ah, well. This, it works, okay? But it's a little wonky when it's in here and it's spinning fast. You can see it kind of not being quite on center. It was fine for when I used to get small rolls, but the larger rolls, I needed to make sure it was not all wobbly like that. Let's see if I can get this out. It's just pressure fitted, I think. But my goodness, that's a tight pressure fit. There we go. Same concept as the new one. These were kind of glued in and pressure fit. This actually broke already, so I hot glued it back together. It was really never meant to be used as much as I used it. Yeah, that's PVC pipe that I had on hand, and then I created some adapters here with 3D printed parts that fit right into the pipe, and then there's a bearing inside. I can't even take this apart anymore. It's jammed in there so well, but is a bearing that fits into the 3D printed part inside of here on each end. And then the bolt is screwed through from the inside before it's inserted into the pipe. So this is pretty smooth, but because it's PVC, it's not perfectly straight, and the pipes don't fit in the 3D printed parts don't fit into the pipes perfectly. So it is not as good as the new version, but it works well enough. See, it doesn't spin freely. It's not quite straight. You can see that wiggling. It's not on center, but it's not even tightened down anymore. So with this type of thing, vibrations are a big deal. They will untighten things. So that's why on my other versions, I have lock nuts for anything that's getting a lot of vibration. You can see the same concept. This is bolted through the bottom with the head recessed. Same themes, just improved in the new version. Okay, I remember now one of the problems that I was having with this. It was glued in here, but sometimes it would get unstuck, and it also just didn't necessarily fit with the tube super well. They were kind of different sizes sometimes, so it wasn't entirely my design's fault. But this would get unglued sometimes, and then it would travel out, and then it would hit against the sides and create too much friction. It wouldn't spin properly. So this kind of just very simple, like not having anything that's grabbing onto the actual part here, it just wasn't good enough. I had some spacer pieces that I would put in here as needed to try and keep it from drifting around on the pipe. But again, there was just this innate issue with if it goes against the side, even if I have the brake loosened, then it makes too much friction. So that is the evolutionary process of my carbon fiber chopper from its first prototype to its current form. I'm sure it could be improved somewhat, but hey, it works, so why would I spend time on changing stuff? So it's an example of like you want to get that minimum viable product to be able to test the idea. I started out with just hand chopping carbon fiber on a cutting mat with a rolling rotary cutter. And let me tell you what, that was very, very, very slow, but it got me started. Okay, this carbon fiber looks really nice. Now I need to figure out how to mechanize this. So from there, we got up to this where it's using a drill, taking that manual aspect out of it. Massive, massive upgrade from hand cutting. There was actually one more intermediate step there. I bought a chopper from a place that was this like chopper gun, and the quality of what was coming out was terrible. It was completely unusable. So I returned that, but I did get the idea for these parts because this center setup here with the blades was the piece that was inside of this chopping gun. But I was able to buy this separately for far cheaper actually, and then just integrate this in my own custom system that gets the best possible quality from a good quality carbon fiber. One more thing that's worth noting here, when you go to all the trouble of chopping really nice carbon fiber like this, if you need to spread it out, you have to be careful, because if you overhandle it, it's going to break up these nice bundles, and it's not going to be nearly as cosmetically pleasing. It'll work fine, but not going to look quite as good. So for that, what I use when I'm using this to make forged carbon fiber fabric is a recycled peanut butter powder container that I've obviously cleaned very well, and then modified the lid to have openings that are just the right size to distribute the carbon without damaging the fibers as much as possible. So I just cut out the center of this and left a lip, and then 3D printed this sort of wide hold sieve. So that just pops in here. You would put your carbon into the canister, not all the way full. You want to fill it probably half to 2/3 full. And then you just screw the lid on, and you can just sprinkle out your carbon, and it will make it faster and less damage than trying to do it by hand or use some other method to spread it. This works quite well.